on this. Uh, what? Yeah, I'm a professional streamer, okay? I'm not a teacher, I'm a professional streamer. Fine. Then pay attention. I'm just kidding.
Hey guys, go power.
All right.
What's your favorite color?
No, this is a good color.
Baby blue.
Oh no.
It looks like it's like he's ready for gender reveal party. It's like pink.
He had a pink back.
He's a girl.
Yeah, he only has 2 boys.
Yeah, he wishes he had a girl.
Yeah, but then I'll probably murder their boyfriend. So.
But you didn't want someone to beat up.
Okay.
No, if I have a girl, I will train her to kick their ass.
I think he'd be nice. He'd be like,
All right, shh. Rogov, shut up. Go away. All right, shh. We are talking about new lesson. All right, chain roll. For some real reason, everybody thought I say chain roll.
Chain?
Like chain, like CHENG. Or chain roll.
Okay.
All right, so let's a chain rule. So if I take a derivative, this is a derivative with respect to x of f of g of x is, well, it's going to be f prime of g of x and the g prime of x. And that's the chain rule. And another definition implicitly is going to be dy dx is equal to dy du times du dx. That's another definition. So there's 2 definitions. When do we have used chain rule? Well, immediately that if you have, for example, we talk about when to avoid quotient rule, right? What are the 3 instances you should avoid quotient rule? If you have constant on the top, constant on the bottom, monomial on the bottom. So those are 3 places you avoid quotient rule. So we're going to talk about this case. 3 over x minus 1 or 2x minus 1 to the first, like this. So I have f of x is equal to this. So let's talk about how do we avoid quotient rule here using chain rule. So this is the one situation that you can use chain rule. But before that, let's go to some basics. Let's start with this question. That says 2x minus 1 to the 5th power. If I were to take a derivative of this, basically understand they are function within the function, right? If the y is equal to f of g of x, what is g of x? 2x minus 1, right? And what would be the f of x? No. X to the which power? 5th. So that way you know that 2x minus 1 is inside of x. So we're going to take the outer function first. So we're taking derivative of the outer function first. So if this is y prime, then I'm just going to treat this whole thing as a function to the 5th power. So that way we know it's just a simple power rule. So it's going to be 5. It's going to be 5 parenthesis 2x minus 1 to the 4th. Does that make sense? But what people usually forget is the derivative of the inner function. Derivative of the inner function is going to be times 2. And this is what people forget. So don't forget that. And then you will get 10 over 2x minus 1 to the fourth power. And that's it. Very easy. So you're going to take a derivative of this one.
Why is it in the denominator? It's not negative.
Oh, I don't know why. Sorry. My fault. My brain is not. No, I was looking at the other function. I was thinking of the other function. 2x minus 1 to the fourth. Is that okay? Okay, so now I won't, because I was looking at here, I was thinking about on bottom for some weird reason. But yeah, I want to take a derivative of the f of x here. Now this one is, yes, can you use quotient rule? Yes. Yes.
So on the homework when there was question like p of t equals f of t times g of t, and you do product rule, you have to do chain rule there also?
No, p of t times g of t is product rule.
No, like f of x times g of x, when you do product rule, you have to do f prime of x times f of x. Chain rule there?
No, it's
There's no chain rule there.
f of x and g of x. But
There's no. You do have a chain rule there, but okay. Let's just say if you have f of x times g of x, right? This is a product rule. This is actually f prime of x times inside. That's chain rule happen. G of x plus f of x times g prime of x, the derivative of the inside, which is 1. So derivative of the x is the chain rule. So if you want to see a chain rule, there's a chain rule there, just kind of invisible because derivative of x, the x does not matter. Now, if you have g of 2x, then it's going to be g prime of 2x times 2. Does that make sense? That's where the chain rule occur. But no, the f of x times g of x, no, they are technically doesn't need a chain rule. Yes.
G of 2 doesn't be 0.
What?
G of 2, that doesn't be 0.
Where's the g of 2?
But like if you had G of 2, would that just be 0?
G of 2? Yeah, because you plug in 2 and you take a derivative of a evaluation, it's going to be a number. Take a derivative of number, it's going to be 0. So g prime of 2, no, depends on what you do. If you says, I guess no, that doesn't make sense. If you do take prime, so your order operation is going to take derivative first. If you take a derivative and then you plug in a value. But if you g prime of 2, that means you take a derivative, plug in a value. It doesn't mean you take a derivative constant. Now, if I have g of 2 of prime, that's always 0 because you find out g of 2 first, which is number. You take a derivative number, it's always 0. So, but usually this notation would never occur. Does that make sense? It's order operation. Okay, I want you to take a derivative of this.
So. Why are you going so slow?
You guys done? So before I use chain rule, right, I'm going to say f of x equal to 3. I avoid quotient rule, so I'm going to change to -1 power. Then can I say f prime of x is equal to 3 times -1 times 2x minus 1 to the -2. But don't forget what? Derivative of the inside, which is 2. So therefore, it's -6 over 2x minus 1 to the 2. So would you rather use chain rule or you rather use quotient rule? Really?
No.
I don't know. I think it's simpler to use chain rule. I don't have to use pencil to do chain rule.
You do that in your head.
Chain rule is easier.
David, you do you.
No. Yeah. You know what? Yeah, listen. You do you, David.
All right.
Now he's gonna be like, solve this. Oh, thank you.
So what's derivative of this?
One.
You're so.
I'm just kidding. Is that a 3 on the outside?
Yeah.
Yeah, it's dirt roots.
A little bit. Do this. He's like,
Yeah. No. You can't.
You can't, exactly.
I said you can. Okay.
There's so many IEP students this year. That means they have extended time on test. No, that's what's thinking. That's such a good idea, Matthew. You're a genius. That's a genius. Matthew, I'm actually thinking about it.
Oh, it's a.
Yeah, that's what's the equivalent of 15 homeless people.
Huh?
I don't know who says what yesterday. It's like he told somebody told Daniel, it's like you should like get investment. Oh, Rebuff was the same. He said like he told Daniel, it's like, yeah, own a lot of investment property and the raise rent on the single mothers. That is so wrong.
That's so bad. That's wrong at so many levels.
Okay, so what happened is you always change the rational exponents. And this is a 4/3. And the trick is, when do you use chain rule? Any other power than the first. If you have 3x minus 2x squared to the first power, you do not need to use chain rule. If you two have 1/2 power, 4/3 power, negative 4/3 power, it doesn't matter which power. Other than 1, chain rule is the way to go. So then, if I take a derivative, the outer function is going to be 4/3 times 3x minus 2x squared to the 1/3 times by the derivative inside, which is 3 minus 4x. And yep, then you're done. You don't have to do any further work. Pretty easy, right? Moving forward. Let's talk about some hard one. Because it's fun. Charlie, it's okay?
Yeah.
Brandon? Yulia? You learned this in Ukraine? She's like, yeah, that's too easy. Can you give me something harder? The damn Russians. Oh no, Ukrainians. It's okay. I've been wanting to get canceled for a long time.
Victory, I think you've already got canceled.
I did once, and you know that. Somebody trying to cancel me once, right?
Oh, yeah. Somebody told me that in the class, you asked if the transfer gas station
You're foul.
Ria?
So foul.
That's so messed up.
No, it's not. It's true.
You said you love black people and pointed to the blackboard.
Yeah. So what?
Like this is a regular blackboard.
You know what? It's fun. All right. So what we're gonna do is we're gonna look at this question and we say, hey, how many rules involved here? And not only how many rules involved here is I'm gonna ask you, say, hey, can you find horizontal tangent?
Yeah.
Okay.
We got me.
So how many horizontal tangent
No.
are they?
Two.
Okay. It's not two.
No, I know. I was just saying.
All right. Shall I do it or you want to do it?
Let's do it.
That you cook, okay.
I don't want to. I don't want to cook.
Okay, Charlie, you want me to help you on the side? Okay.
The side is crazy.
Well, I'm gonna do it on the whiteboard.
It says
I do.
I don't know Yulia or Brenner
I really never
Charlie can help. But if I have, like, say, 2x plus 1 to the third power, and
Yeah, so leave me alone.
like 3x minus 2 to the second power.
Oh, I
There was 2 rules involved. There's a product rule.
I
And there's a
hated
chain
this
rule.
question, bro.
I think I just like
Is that okay? So that's gonna be 3,
Now he's like,
2x plus 1 to the second
where you do it.
times
In the
3
graph.
times
I
2
practiced this question so
times
many
3x
times.
The
minus 2
graph
to the
was the
second.
questions I thought I would be okay on the test.
Plus,
I didn't have time.
This one, leave out this one alone, 2x plus 1. And I take it to this one, so yeah. Times 2 of them inside. Like usually people have 3 and people have 2. This is the You got that?
Yes! What am I gonna do, man?
Marco, Stefan, you guys have to actually get work done. All I hear is you guys cracking up for doing something.
And I'm doing it while cracking up.
No, I need you to do it without cracking up.
Okay.
Because I'm trying to teach.
Okay.
You don't let me cook. Okay, so I'm gonna back out the most negative, so 2x plus 1. That is the most negative here. And I'm gonna look at this. This is the most negative. Does that make sense? Now put a bracket. And I probably factor out 6 as well. Because 2 times 3, 2 times 3, that's 6. Is that okay? And then what do I have left? I have 3x minus 2. Right? Because I want 3x minus 2 left. And I'll have minus plus 2x plus 1. So that's 2x plus 1 to the second times 3x minus 2 times 5x minus 1, right? That's 6 in the front. Now, if I want to find horizontal tangent, then that's going to be 1/2 negative. X is equal to 2 over 3.
Okay, this
And
first.
x is equal to 5.
Okay.
So there are 3 horizontal tangent here.
I believe I did it right.
I don't remember. With the least, the lowest number, lowest exponent. So then what I would take out, right? 3x.
Minus 2 to the power of 3 and 5x minus 2. So then the horizontal tangents are
Wait, cancel it. Okay, so. Okay, wait. Okay, so. Oh, so I didn't. Okay, so I shouldn't have combined it. Okay, so I'm gonna do.
I practiced this question so much last year because there's so many. I didn't get the fact.
I got you. I understand. So then what, can't you take the 3 out? Because then you can do 15 and 4. So if you take the 3 out. So then you get 12.
That's to the 4th power,
plus
sorry.
x minus
You haven't do it to an X power yet.
You can take out any exponent here.
Huh?
You're talking to me, right?
Talking to Yulia.
Oh.
You thought that was an X too?
No, no, I thought.
Oh, okay. Huh?
Where is the?
Thanks, man.
But where do you see that?
I can always ask for your support. All right, I'm gonna take a derivative. Product rule 4 and the chain rule combination 3. But don't forget this 3 right here because that's what people forget. The derivative of the inside function. So most people forget that 3, and I don't know why, and I don't know. But anyway, so don't forget that 3 because that's a chain rule. And then you got 5x minus 2 to the third power plus 3x minus 2 to the fourth power times 3 times 5x minus 2 to the second. Did I forget anything?
You forgot to take the derivative inside. So
Derivative inside is what? 5. Okay, good. So I can take out a 3 because they both have 3. I can take out the most negative power, is just 3x minus 2 to the third. And I can take out 5x minus 2 to the second, hopefully. Then I have a bracket. What do I have left? 4 times 5x minus 2. And then plus 5 times what? 3x minus 2 to the first, right? So that's going to be 20x minus 8 plus 15x minus 10. So that's equal to 35x minus 18, I think.
yeah.
Now, if I were to ask you horizontal tangent, then you could have said x equal to 2 over 3, x equal to 2 over 5, x equal to 18 over 35. So there's 3 horizontal tangent here if I were to ask you horizontal tangent. So not only I'll ask you derivative, I will usually ask you a continuation after derivative, right? I will ask you, hey, find the slope at x equal to 5. Then you gotta plug in 5. If I ask you find the derivative horizontal tangent, it's derivative equal to 0. Got it? You guys are geniuses. We're gonna move on. How about the situations here? Now, last year I go through this. Everybody hated me for it. Is I want you to take a derivative, and not only that, I want you to simplify the right way. That means factor out the most negative power. Factor out the most negative powers. Yeah.
Show you what we did in physics.
Not yet.
You guys actually help. But like linear and
So he just played.
a video and he's like, watch. Watching with
It was really
And
bad.
we're teaching him how to do it, actually.
Actually, I don't against that idea, because sometimes you learn more by teaching other people.
Yeah, but
And just help with it.
Yeah, my biggest issue is that it's like we're a month in and we haven't even gotten to schematics.
no.
You're not coverage through the whole year's been. There's no way.
That's why I told you Walter Lewin is a good professor. You watch his lectures. Walter Lewin, he taught at MIT for 20 years. He does the most fantastic lectures. His lecture has very important informations. I love his experiments. He's the person that inspired me to be a honor teacher. Him and Ronald Clark. Ron Clark is another one.
Oh, he has that cat, yeah.
He has a Ron Clark Academy. He taught in Atlanta. He basically teach all the kids that are underprivileged, and he trained them to become like future like engineering doctors. Yeah, he has his own school. Delta Airlines sponsor his school. Coca-Cola sponsor his school. Disney sponsor his school. If I win a lottery, then that will be the things I want to do. I want to open up my math school. I want to open my school that teach kids how to do math properly. So if you guys will become rich one day and you want to sponsor me, let me know.
If you remember us.
I'll be like, who are you? Ivy?
Come back next year as teacher. I'm gonna see if you remember or not.
Zidane, I can never forget you, Zidane.
You really blush.
I don't even know if I did that right.
No, wait. Okay.
Remember factor out the most negative power, so it gets kind of tricky.
When would
Last year you guys have so much hard time. Hopefully this year you have no hard time.
I don't even have it as a student anymore. No?
What?
Calling Ivy, do you even have it as a student anymore?
I told you I had a student in my Ivy Nguyen.
Yeah, but how long ago?
What are you doing? I call her brother. I tell him. Ivy is cool though. He's really cool. It's just Kelly. Isn't it?
It's an old white lady name.
Yeah.
Okay, I get it.
I just can think of like, which Asian person you know named Kelly?
Me.
Besides you. Besides you.
I have met somebody.
I never met any Vietnamese or Chinese named Kelly.
I think that's a you problem.
Okay.
Kelly, what answer?
Okay, I'm gonna take a derivative of this, so it'll be 2x times 1 minus x squared to the 1/2 power plus x squared times 1/2 times 1 minus x squared to the negative 1/2 and the times negative 2x, which is people usually forget this one. But what happened is I will actually get rid of 2 here. That makes that integers. And I will factor out the most negative. Now, what's the most negative in terms of x and x squared? X, right? And what's the most negative of 1 minus x squared? Minus 1/2. Okay, so that's a negative 1/2. And once you factor out, we're gonna see what happened. So there's a 2 here. There's a 2 here. Is that okay? And then there is a 1 minus x squared to the what? 1? Good. So 1. And then what happened to the second one? You can factor out x. And the x times x is x squared. So it'd be negative x squared, I believe. X to the, wait, x to the... It's x squared, right?
X.
Oh, never mind. Yeah. It is.
Oh, I'm sorry. I got it.
Okay, I got it.
Is my eye upside down?
Wait. Wait, like look here. Is it actually upside
Bro just turns the class with my eye upside down.
Wait, that was live stream? Okay, I'm gonna watch live.
I'm gonna say there's never a dull moment in this class.
Mr. Ye, why don't you wear an iPad?
You know?
Yeah, you look so cool. That'd be fire.
You
though.
look tough.
No.
Why don't no?
I want to get a Sharingan eye.
Oh, you should get a monocle because your glasses only work on one eye, right?
Amio, you fact out an X.
Oh, he has glasses? You sure he has glasses?
Yeah, you can wear a monocle instead. One lens.
That looks so
Oh,
corny.
oh, he's pretty bleached.
What's so? It's not a monocle, not the like it's such a
No, it doesn't look cool. I think that one. I think Mr. Yates. Don't listen to Mr. Yates.
Nobody said anything.
I think your eye is very weighted.
Wait, obviously it seems like you don't.
All right, so is that okay?
Yeah.
Yeah.
Are we done?
No, how much time I have?
3
2
minutes.
minutes.
2 minutes?
Oh, do you have the homework?
2 minutes, yeah. Are we done?
Oh, also don't forget to do the homework before you.
Okay, I'm gonna teach you one more question. So y equal to this one is a something that 4 to the 10 of square root x. Now you did this last year. Is there is a bubbles within the bubbles within the bubbles.
Oh, yeah. Okay, we got to do.
Okay, so there's a function within the function within the function within the functions. So I usually rewrite this. As sine of 10 of square root x like this, and to the 4th power. Why did I do that? Because if I do that, I can see which functions within which function. So I draw my first bubble. First bubble is this one. It's something to the 4th power. And I'm going to take a derivative of that. The second one, I'm going to take a derivative of this. Does that make sense? The second one is going to be this bubble right here. And the third one is going to be this bubble right here. And the fourth one is going to be this bubble right here. So they are function within a function within a function within a function. So if I take a derivative of this, it's going to be 4 sine of whatever inside is. I'm just keep inside the straight the same. And to the 3rd power. So I only take out the red bubble here. I only do the first outer derivative. Then I'm going to go in. The second layer is sine of tangent of square root x. So derivative of sine is going to be cosine of tangent of square root x. Is that okay?
Yes.
Now the third layer is going to be secant squared
Square root x.
and the square root x. And then lastly, take a 1 derivative of that. Sorry, 1 over x to the negative 1/2.
But does the 4 is like just in the.
So 2
Okay.
over square root x times sine of tangent square root x to the 3rd.
We're writing all of that. Simplified to that.
You really want to. Mr. Yates, or don't forget the homework before you leave.
And apparently, Chandler and them are like history, Mr. Yang.
Don't grade all. Grade certain people. Grade Safa. Safa is easy to grade. I'm gonna give you the easy one to grade because some people need like maybe 10 more minutes to finish the test.
That's not.
Bye.
You do SAT and it's student, right?
Yeah.
When do you do that?
I can't do that to my own student. I can't really charge my student.
You can't what?
I do it for a fee.
Okay.
I don't do it for free.
Yeah.
And I cannot do that to my own kids.
Can't do it to us here.
I can help you at lunchtime if you want to come at lunchtime. I don't mind to help.
Okay.
Yeah, so lunchtime, it's fine. I'll just post questions. I'll talk about it. That's fine. But I can't really charge you guys because it would be a little bit of conflict interest. That's like a lot of conflict interest, to be honest. But I mean, I won't get fired or anything. It just, I actually can, but I don't want to.
Okay.
I'd rather help out in general to my own students. But if other people ask me to help out, you have to pay. But I'd rather you come in. I can give you some problem. It's not a problem. Like just give you a problem, talk about strategy and stuff like that. That's no problem.
Thank you.
And I don't think you're gonna need a lot of help. I think you just need to
study.
clean up something like small things.
Yeah.
But I don't know which lunch you have. Which lunch you have?
I have a lunch.
You know, yeah, you're more welcome to come in to work on SAT problems and stuff like that. It doesn't bother me.
Thank you.
End the stream, Mr. Yuri.
What?
End the stream.